Modern paints are actually far more complicated materials than traditional paints. With modern paints you can find over 10, 11 components in a paint in addition to a pigment and a binder. They are highly proprietary in nature. Even though the artist paint market is a relatively small one, the individual companies have trade secrets. It's therefore just not possible to read or to ask people what's in these paints and be told the answer. So we have to figure this out for ourselves. We need to understand these new materials so that appropriate conservation strategies can then be developed to help preserve modern and contemporary painted works of art. The first step in deciding how best to preserve any material is nearly always analysing them. And what that means, unfortunately, is a huge amount of background work. In the sort of traditional old master era, there has been a huge amount of work looking at what pigments were used, how paints were made, how they were using them. Now in the 20th century, the paints that are being used are just different. The 60s in particular, with the introduction of acrylic emulsion paints, suddenly saw many other artists using synthetic paints. Warhol, Hockney, Sam Francis, they were using these paints quite widely. These paints were far more rapid drying than oil paints. Acrylic emulsion paints can often also be applied directly to a canvas, so you don't need this long preparation. The conservation profession has to understand these paints in terms of how to identify them on paintings, and how they might last with age, how they might be affected by treatments that we're routinely carrying out.
We wanted to develop better analytical methods to identify the materials, specifically the modern oil paint media and synthetic pigments, for which there really was no good analytical technique for identifying all of them in small samples of paint. We also wanted to study the mechanical response of acrylic emulsion paint media, one of the most common paint media today. The information from our research would inform the conservators about what materials they're really treating. Another aspect of our work then is just to make reference materials from these commercial products. We paint them out onto glass, aluminum foil, plastic sheets, and after they dry, then they're ready for us to study. In our reference collection at the GCI, we have hundreds, if not thousands, of commercial products that are here for our study, but also for other serious researchers. To characterize the oil paint media, we'd use quantitative gas chromatography, where we measure the amounts of the different components in the modern oil paints. We'd also use mass spectrometry, or DTMS, to identify the synthetic organic pigments. With DTMS, you use a tiny speck of paint and you heat the paint sample on a wire inside of a mass spectrometer. You need very, very little material in order to characterize the pigments, but you can characterize most synthetic pigments with that technique. We use thermal analysis, an umbrella term that describes any number of techniques that measure some property of a sample as you heat it up. So the one that we've used most is thermomechanical analysis. We take a small sliver of paint, we put it inside of a tiny furnace, and then we measure the height of the sample as we heat it up. As the paint medium gets warmer, the plastic starts to soften and deform, and so we can register that as a change in sample height on the graph. The aging equipment basically simulates the three environmental parameters that cause the biggest chemical and physical changes to materials: relative humidity, temperature, and light. Once inside the aging chamber, the paint samples are subjected to those three environmental parameters. After a month or 2 or 3 of living in those chambers, we take the samples out and we look at them. We see physically how they've changed. We also can analyze them with our test methods to see how they've changed chemically.
A large part of this project is about preventive conservation, is about anticipating changes that might happen to these paints. With modern paints, we have this incredible opportunity to try and understand what might occur over the next decade, centuries. And if there are things that we can do to slow that down or to prevent it happening, then it's the best time to do that is now.
We're very eager to get the information out about these new test methods. We publish all of our results, talk about them at seminars and symposia, and sometimes we have workshops where we teach people the hands-on of doing the test methods.
A lot of the work we're doing is on test paints, where we can really try things out and understand the effects of treatments of aging. When we start applying those to works of art, the hope is that the treatments that we're developing won't be apparent. We won't see these big changes in before and after treatment because we're actually preventing the need to do that. We are trying to anticipate how these materials might change with age, might be affected by treatments, and once we know that, then we can just make sure that the art itself is being looked after in the best way, and that can only do one thing, which is to prolong the lifetime of these works for generations and generations to enjoy.